This first graph shows the force that the performer produced in their jump. The weakest performer produced 2.3 newtons of force in the jump. This was less than the group average of 3 newtons. However, the strongest performer produced 3.4 newtons of force in their jump. The force contributes to the height of the jump, so the weaker performer would not be able to jump as high in the air as the stronger performer. This second graph shows the duration of the braking and propulsion phase of the jump. The performer's phase lasted 0.504 seconds, which was a bit less than the group average of 5.3, however much higher than the strongest performer, whose duration of the phase is only 0.405. The force produced and the duration it produced results in the impulse of the jump, which is shown in this last graph. Although the weaker performer had a higher duration of the phase, their force was significantly lower, so this is why their impulse is lower than the stronger performer. The weaker performer's impulse was 141 newtons per second, whereas the stronger performer's impulse was 276 newtons per second. Their score was also lower than the group average, which was 201.77 newtons per second. These graphs show the performer's velocity, power and acceleration of their jump compared to the stronger performer and the group mean. Their velocity is 2.3 meters per second, which is lower than the group average of 3 meters per second and much lower than the stronger performer, whose velocity was 3.4 meters per second. Both their power and acceleration were also lower than the group mean. The power produced in their jump was 644.11 watts, lower than the group average of 1,253, and the strongest performer, whose power was 2,329.75 watts. Their acceleration was 4.58 meters per second, whereas the group's mean was 5.89 meters per second, and the strongest performer's acceleration was much higher at 8.45 meters per second. Acceleration relates to velocity, so if there's a change in this, this will affect the acceleration of their jump. These graphs show the height of the jump and the time the performer was in the air. All the other factors from the previous graphs contribute to this jump itself, so if the performer increased, for instance, the force they produced, then this would influence the height of the jump and therefore the time in the air. As the weaker performer didn't do as well on these other factors, this influenced their jump, and therefore they didn't jump as high, only 0.20 meters, and didn't have as high time in the air, only 0.4 seconds. However, the stronger performer, as they achieved higher on the other factors, had a jump height of 0.49 meters and was in the air for 0.63 seconds. Compared to the group average of the jump height of 0.32 meters and 0.51 seconds in the air, the weaker performer has a lower jump, whereas the other performer jumped higher than the average. To improve their jump, any of the other factors shown in the graphs would have to change. For example, if the force increased, then the jump would improve.